Functional groups and homologous series. Functional groups are atoms or group of atoms in an organic molecule which characterize its chemical properties and enables it to react in specific ways. Means the atoms or group of atoms which has reactivity site. That reactivity site is the functional groups. So we start with class of compound alkane. The class of compound alkane has no functional group. Alkane has no functional groups. Usually C single bond C, and then alkene. Alkene C double bond C. The functional group of class of compound alkene is carbon-carbon double bond. So don't interchange the class of compound and functional group. If the question asks class of compound, if you look at the C double bond C, that class of compound is alkene. If the question asks functional group, not alkene. Functional group is carbon-carbon double bond. Next, class of compound alkyne. That's for C triple bond C. Functional group carbon-carbon triple bond. Aromatic class of compound. The structure is cyclic structure C double bond C alternate with C single bond C. So here C double bond C, C single bond C, C double bond C, C single bond C, and the total 6 carbon. You call it class of compound aromatic. And the functional group aromatic ring. If the question asks for functional group, you just write down aromatic. That is wrong. Aromatic is class of compound. The functional group is aromatic ring. Next, class of compound haloalkane or alkyl halide is when you see the C single bond with any group 17. F, Cl, Br, I. So that is class of compound haloalkane or alkyl halide. The functional group for alkyl halide is halogen. Okay, this is functional group halogen. Next class of compound alcohol. The structure is C single bond with O single bond with H. Okay, C single bond with O and then the O single bond with H. That is class of compound alcohol. The functional group for alcohol is hydroxyl. Hydroxyl. Next class of compound is phenol. Phenol, the structure has the same as in class of compound alcohol, but when the carbon, so this carbon single bond with O, the O single bond with H, that carbon has benzene ring. The carbon is the carbon in the benzene ring. So you call it phenol, not alcohol anymore. The class of compound is not alcohol anymore. It is phenol. The carbon benzene ring, single bond with O, the O single bond with H. So the functional group of phenol is the same as functional group of alcohol, which is hydroxyl. Next class of compound, ether. Ether has the structure of C single bond O single bond C. And then the functional group for ether is alkoxy. Next, aldehyde class of compound. This is the structure of aldehyde. The carbon double bond with O and that carbon has single bond with H. Our group means any group attached to this carbon. So aldehyde, we focus on the carbon double bond O and that same carbon has one single bond with H. So that is class of compound aldehyde. The functional group of aldehyde is carbonyl. Next is ketone. Ketone, the carbon is double bond O attached to double bond O, and that carbon has no hydrogen attached to that carbon. If one hydrogen attached to carbon double bond O, it is aldehyde. For ketone, no hydrogen attached to that carbon which has double bond O. The R group means other group or other carbon. Can be carbon here, but no hydrogen attached to this carbon double bond O. So that is ketone. The functional group is the same. Carbonyl means C double bond O, so carbonyl. That's why they have the same functional group, because both have C double bond O. Next, class of compound, carboxylic acid. Carboxylic acid, the structure is C double bond O, and that C has single bond OH. Okay, the same carbon that has double bond O attached to OH. That is carboxylic acid. The functional group is carboxyl. Next, ester. Ester, the structure is C double bond O. That C has single bond O, and that O attached to R group. R group can be other C, not hydrogen. If hydrogen, carboxylic acid. The C double bond O, that same C double bond O attached to single bond to oxygen, and that oxygen is single bond with other carbon. So that is ester. Carboalkoxy functional group. Ester, the functional group, carboalkoxy. Next, acid chloride or acyl chloride class of compound, and the structure is C double bond O. That carbon double bond O attached to Cl. That's why the name is chloride. That carbon must attach to Cl. So this is acid chloride or acyl chloride class of compound. The functional group is acyl halide or acid chloride. Can also be the functional group, or acyl halide. Next, anhydride. Anhydride class of compound, the structure C single bond O single bond C. So this is anhydride, C single bond O, and then that O single bond C. Both carbon has double bond with oxygen. So this is the structure of class of compound anhydride, and the functional group is also anhydride. Next is class of compound amide. Amide, C double bond O, and that carbon, the carbon that is double bond O, is single bond with N. That C double bond O is single bond with N. That is class of compound amide. The functional group is carboxamide. Next class of compound amine. Amine has C single bond N, and that N bonded to other two hydrogen. That is amine. The functional group is amino. Class of compound nitrile has carbon triple bond with nitrogen. The functional group is cyano group. A series is a series of compounds where each member differs from the next member by the addition of CH2. If they have the same class of compound and functional group, they are in the same homologous series except for cyclo. Cyclo, even though alkane, cycloalkane and alkane, they have the same class of compound, but for cyclo, they are in different homologous series. The members of the same series are called homologues. So methane, ethane, propane, they are in the same class of compound, which is alkane class of compound, but the only difference in them are the number of carbon. So methane has 1 carbon, ethane 2 carbons, propane 3 carbons. They have the same class of compound, so we call them, they are in the same homologous series. Same goes to methanol, ethanol, propanol. The class of compound are the same, which is alcohol. The only difference is the addition of carbon. So here, 1 carbon methanol, 2 carbon ethanol, 3 carbon propanol. So they are in the same homologous series. General formula, homologous series. So for alkane, general formula CnH2n plus 2. So the ending name for alkane, A and E. So for methane, 1 carbon methane, 2 carbon ethane, 3 carbon propane. So ending name ane. So for alkene, the general formula CnH2n. So this N is the number of carbon. So if you put 2 carbon here, the hydrogen will be 4. So for alkene, if that alkene has 2 carbon, that alkene has 4 hydrogen. So this is a general formula for alkene. Ending name in. So we start with ethene, propene, butene. So in ending name. Alkyne has general formula alkyne C triple bond C, general formula CnH2n minus 2. So the ending name is ine. Next, alcohol. Alcohol, general formula OH, ROH, so ending name OL, and so on. For aldehyde, AL, for ketone, ON, for carboxylic acid, ending name oic acid, amine, RNH2, ending name amine, amide, ending name amide. R normally refer to alkyl group with general formula CnH2n plus 1. If it is cyclic compound, you have to reduce 2 hydrogen atom for the cyclic compound. For example, alkane, if it is cycloalkane, you have to reduce 2 hydrogen atom from its original formula of alkene. If it is alkene, CnH2n, the general formula for cyclic alkene, you have to reduce 2 hydrogen atoms from the original general formula. For this one, let's see, we start with propane. Cyclopropane, because there's no cyclic. If there is 1 carbon for alkane, you cannot form cyclic structure. Same goes for ethane, you cannot form cyclic structure. So we start with propane, 3 carbons. This is the structure of cyclopropane. If it's not cyclic, it's just a straight chain, carbon, single bond with carbon, single bond with another carbon. And this is cyclobutane, this is cyclopentane. And if you look at the general formula, if alkane, CnH2n plus 2, for cyclic, you have to reduce 2 hydrogen atoms, so it's just CnH2n. Next, for alkene, again we start with propene, okay, because you need 3 carbon at least to form cyclic, and there's no methane because you need C double bond C, because meth means 1, so there's no methane. We start with ethene, C double bond C, and there's no cycloalkene for 2 carbons because you cannot form cyclic if you have 2 carbons atom only. So if you look at the general formula for alkene is CnH2n. The general formula for cycloalkene, you have to reduce 2 hydrogen, so CnH2n minus 2. And this is cyclobutene, this is cyclopentene. In name at the back means it is alkene, C double bond C. alkanes and cycloalkene belong to the same class of compound but different homologous series. So here, methane, ethane, propane, butane, pentane, they are in the same homologous series. Again, this alkane, even though it is alkane, but it is cyclic structure, so they are in different homologous series.